All right, let's talk about direct variation for a little bit. Direct variation is you vary directly, I should say. And so when we talk about slope, we're talking about slope as varying between two specific coordinates. And so we're talking about it goes some space x and some space y. So some space x and some space y. Some space x and some space y. The slope is the rate, right? But if you vary directly, you vary directly from a point. In mathematics, when they talk about direct variation, that direct means you're varying directly from the origin. And so when we talk about direct variation, we're talking about it goes directly from the origin. So if we were to graph something like that, we always, in terms of direct variation, we always start at the origin. And so I'm going to plot a point right there at the origin because that's where I'm going to start. Another way to think of this, if you're familiar with slope-intercept form already, then you know that b is 0. And so you know you need to start at the origin anyhow. But if you're not familiar with that, just follow my steps here. And so if this is a direct variation equation in the form of y equals k times x, we start at the origin. Then we use the slope to determine our next point. And so our slope is 3, which can be rewritten as 3 over 1. And so a positive in your numerator means you rise 3 spaces up. A positive in your denominator position means you run 1 space to the right. Positive is to the right, negative is to the left. Positive in your numerator is up, negative in your numerator is down. And so 3 spaces up, 1, 2, 3. 1 space to the right, 1. Here is my next point. Now, generally, when we graphed lines before, we graphed using 5 points. When using direct variation, we're only going to use 2. And so we have what we need. We have our 2 points. And then you just draw your line through the 2 points. Let's try another one. This time they give us a negative 3, y equals a negative 3 over 4x. And so in direct variation, because of that word direct, we always start where?
At the origin.
At the origin. So I'm going to plot my point at the origin. Then my slope is negative 3 over 4. Slope is in this position here. It's always the coefficient to x once y is solved for. And so the negative in the numerator means we go up or down.
Down.
Which one?
Down.
Down. And the positive in the denominator means we go
Right.
right. And so I'm going to go down 3 spaces, 1, 2, 3, and to the right 4, 1, 2, 3, 4. And so now it's graphed. Another thing you can do is you can put that negative sign either way, any place you want it. Just make sure there's only 1 in that fraction. So I can also rewrite this as 3 over negative 4. And then I can go 3 spaces up and 4 spaces to the left. And that line should still, 2, 3, 4, be in that path. Should still be a straight line in that path. Either way you cut it. So here's the alternative way to graph it, and here's the way we graphed it at first. Let's talk a little more about direct variation. If I'm using direct variation, then I know that they might give me problems like this. Is x, if y is negative 8 when x is negative 2, what's the equation for that? And so what I'm going to do is write a direct variation equation in general form, and then I'm going to substitute a negative 8 in for y, and then substitute a negative 2 in for x. Let's do that now. Once doing that, I can solve for k, or what they call the constant of variation, which is also your slope. I know that k equals 4 here, because negative 8 divided by negative 2 is 4. And so then I know my equation, if I were to put my k in my equation, is y equals 4x. This is my equation. Once I have that equation, I can answer whatever question they're asking me. They're saying find x when y equals 32. And so I'm going to substitute the 32 in for y. 32 equals 4 times x. And then solve for x. Well, x has to equal 8 because 4 times 8 is 32. So generally, when I'm giving credit for this, I'm going to give 2 credit points, or if I'm giving 1 point for the problem, I'll give halves. One part of the problem is to write the equation. The second part of the problem is to solve for whatever they're asking you to solve for. Let's take another look at it. Write the base equation out first. Y equals k times x. What do I substitute in for y?
45.
45. I'm going to put that in here. I don't know k. What do I substitute in for x?
15.
15. And so I'm going to divide 15 by both sides to find k. 45 divided by 15 is 3. And so I'm going to rewrite that equation out. So I'm just going to put something into place for k. Y equals what?
3.
15.
3
Y equals 3 what?
times 15.
If I'm going to write this equation out, it's going to be linear and it's going to be varying directly. I need to make
3x.
sure that I have my x and my y there. And so yes, 3x. Now that is my equation. That's my half credit right there. Let's get full credit by doing what they ask us to do. They want us to find x when y equals 15. So I'm going to substitute that 15 in for that y. 15 now equals 3x. Then I know that x has to equal 5. Now that's full credit.